Good afternoon, everybody. I'm Rich Lonado, and I'm the only guy here who's not from Dayton or Columbus. So my company, El Paso Instruments, and my partners are located in the Youngstown Business Incubator. What I want to chat with you today is focusing on the Internet of Things, which I'm sure all of you have heard about, and I'm sure all of you have heard about the industrial Internet of Things because it's a huge space. But I want to talk about our company's focus on an IoT solution and a very small subset of the domestic manufacturing space of great importance to the state of Ohio. The state of Ohio is the state with the most foundries in it for metal casting. And for those of you who know a little bit about metal casting, please ignore the next 30 seconds. But for those of you who don't, let's chat about it very quickly. So essentially in the metal casting or sand casting process, people assemble sand molds that are put together and instrumented according to whatever part you need to make. And then they're moved to a point in the small plant or medium-sized foundry in which molten metal is poured. And in the aerospace sector, that molten metal is often aluminum or magnesium. Now, as the metal is poured into this, the metal cools, it solidifies, and after a period of time, the whole mold is broken apart and the near net shape is ground and then machined to end up with a high value, low volume aerospace part, which is highly inspected, as you can imagine, because of its critical importance. And process monitoring information is shared by the foundry to the original equipment manufacturer. And oftentimes where we're at right now in the state of the technologies, thermocouples might be inserted in to capture, say, temperature of the metal during the pour, and it is manually written down and shared with the original equipment manufacturer. Now, a quick story I'll tell you was at an aerospace foundry, and what I found interesting was after they did all of this work, I saw a bunch of these high-value castings sitting by a dock, and I said, why are you guys waiting to get these off your dock because you didn't get paid? And he said it's the process of the original equipment manufacturer has to see the x-ray data, dye penetrant data, and so before they accept that part, there's this time frame by which essentially the foundry becomes a bank. It pays for all of the energy, all of the material, and all of the labor, and until that part is sold and accepted, the foundry doesn't make money. So that's our idea, is to focus on automating some of the data capture that occurs right here and ensure that data is able to be transmitted wirelessly with no labor input to a graphical user interface and ultimately to a cloud of which the OEM can see, and it would speed acceptance of that part and the cash flow to the foundry and reduce scrap. So here's our tailored IoT solution. Dr. McDonald, my partner, created some sensors that have built-in power and are capturing the right information. And in this case, we depict them being inserted into a printed 3D mold of which is assembled into the cope and drag or the shell of the mold. And we check to see if in fact we can pick up that information wirelessly and ultimately ensure traceability. But look at the data, analyze it, and ensure process repeatability, reduce process variability, so you have a casting produced correctly on the first pour, ideally, and reduce all of those costs and the time for the customer to get paid. So here's a little video, and I'm telling you, this presentation should burn you up with desire to invest in our small businesses technology. Here you see magnesium being poured in a Ravenna foundry. We have some thermocouples that are connected to a sensor suite, which is transmitting some of the information, believe it or not, wirelessly, in this case, the Dr. McDonald cell phone. And of course, we want to get that distance a little bit further than it currently is, so we could find those parameters by which the molten metal is going in. And in about 13 to 17 seconds, those sensors, which are inserted in the mold, are actually burnt up, okay? So now we have that data. We could take a look and say, did we reach the right temperatures, which modeling data said we need for that particular material to solidify appropriately and make sure there's no inclusions or gases or points interior to that mold. So we're enabling an inside look of what's going on real time. Regarding market validation, it's interesting. Again, Ohio is a strong defense state with lots of aerospace. And you would note that out of all the maintenance repair operations and the call for parts, castings along with forgings represent the longest lead time to get a certified part on a car, so to speak. In this case, I show a picture of a CH-53, and Sikorsky was behind delivery to the Navy on these platforms, part of because a problem at a foundry and what they were making for powertrain parts. So it's an interesting problem to solve, and we could reduce that time by which parts are made efficiently and then put on a platform to increase platform operational availability. What we think we want to do with our technology is to take a look at the value proposition of wireless sensors enabling IoT in a few foundries to do tech demos, and then find some early adopters in our state along with other states, and then ultimately sell that value proposition across the country in the foundry space, and probably do some pivots to other small manufacturing sectors that are being overlooked by high-end solutions. So if we look at the integration into a specific foundry, part of the challenge here is getting the integration cost down, right? There's no engineers in a foundry typically. So how would you give them these sensors and the hardware so that they quickly integrate it into their process and do so quickly and see value proposition in a way that helps to communicate it? And we could do this over and over again through foundries throughout the country and so forth. So where do we think our competitive advantage is? Right now, there's a lot of IoT solutions out there that are typically higher end and looking at medium manufacturers on a small foundry that's producing a few parts a week. Those typical solutions don't have a business case, but we also want to partner with OEMs in some of our tech demos who might help to drive why a small business needs to integrate our technology. So we see it as a gap, and we see it at the play as a first to market. In terms of market adoption, the Non-Ferrous Foundry Society has given the University of Northern Iowa a $10,000 grant where we advance the technology. And if you see the little thing there, AFS has just announced, I think it's a $53,000 or $55,000 grant that they're giving El Paso Instruments to go ahead and do some additional research around this and some more tech demos. We need to pair that up with more non-dilutive capital in the forms of SBIRs and SITRs with Department of Energy and Department of Defense as our near-term targets, so we can advance this technology, see what our IP is and what our value proposition is, what our subscription rates, and advance the model so that we can go after some other types of capital investment and accelerate our entrance and dominance into the marketplace.
8.5 minutes.
So the key takeaways here we have for you today are this. First, in this big piece of cake in terms of IoT, how do we make a very specific industrial IoT solution of value here in Ohio with metal casting companies who provide high value, low volume aerospace parts? And can we speed acceptance? Can we reduce process variability, reduce energy and material waste, and do so in a manner that allows us to spread this and lift and shift customized and tailorable IoT solutions, which have to be low cost, so that small and medium mom and pop shops, which make up the bulk of US domestic manufacturing, can afford those technologies and integrate them in so they can be more globally competitive. And what we would look for you as investors is to join us on that journey as we move along in meeting that market niche and in that point of discovery, ensuring seamless investment of capital so we could accelerate our company's growth and find the right talent and the right business model so that we could do so in a timely manner. Thank you for your time and spending all this time on a Friday afternoon with all of us. And I look forward to answering any questions that you have.
Rich, right.